class is on port programming. So what do you mean by port? So our microcontroller 8051 is having 4 ports. They named port 0, port 1, port 2, port 3. Port programming means how we can configure these ports as whether input port or output port. Okay, let's begin with okay, once again. Port programming of a microcontroller means how we can configure its port to read data from port and how to write data into port. So meaning of port programming, it's a very simple concept. How we can read the data from the port, how we can write data to the port. That is what we mean by port programming. Okay, microcontroller is having 4 ports, each of 8-bit, which can be configured either as input port or output port. That's all we know already. To configure as input logic 1 must write into the port. Okay, so before reading the data from the input port, the port must be written with logic 1. That is what is required by the structure of the some ports, not all ports, some ports. So basically the concept is to configure the port as input, we must write logic 1, okay, or FF must send to the corresponding port. And to configure as output port, logic 0 must write into the port. So logic 0, 0 must write to the port to make it as a output port. That is not compulsory, but the configuring as input by writing logic 1 or FF to corresponding ports is a compulsory part to protect the port. Okay. Then we'll begin with the simple programming. Write an 8051C program to get a byte of data from port 1, wait for some time, and then send it to port P2. Okay, even though this program while reading it seems it's complicated, but that's very simple by using 8051 microcontroller. What it is saying, we need to scan the port 1. Okay, whatever the data from port 1 is having, port 1.0 to 1.7. 1.0 we need to send into 2.0 and etc. 1.7 we need to send into P2.7. Okay, so after the microcontroller read some data, it have to wait for some time. After that delay, we need to send into port P2. Let us check how we can implement this simple project. Okay, so program is, as usual, we have the hash include statement. Okay, so hash include reg51.h, then reg51.h oid main. So header file is included, then main program is started here. Then we have the char or character byte, unsigned character byte is declared here, and the character name is my byte. Okay, so the data read from the port P1 will copy to my byte, and my byte will be sent to the port 2 later. Okay, so unsigned int x, we have a 16-bit character, this is an 8-bit character, and this is this is a 16-bit character. We have 8-bit my byte character and 16-bit x character to define the delay. Okay, so P1 is equal to 0xFF. What does it mean? P1 is equal to P1 in 80 or reg51 is declared as port 1, is defined as port 1. So we are sending port 1 to 0xFF. Actually, what is FF? FF means 1111. Then second F means 1111. So we are actually writing logic 1 to P1.7 etc. P1.0. Every bit of the port 1 is written with a 1 to make port 1 as input port. So this is a compulsory part to configure the port as input port. While configuring output is not compulsory, we can do without writing 00 to port 2. Now, while 1, what does it mean? While 1 means while true. So true, this condition is always true. While true means something is always true. It's like an infinite loop. So our program, after you write a program to get byte from the port P1, wait for some time and then send it to P2. So always our program will monitor port 1, will read port 1. So my byte, it's declared as a character, and my byte is equal to P1. So microcontroller starts reading port 1, always get a byte. After it written or read by the microcontroller, then this part is what you called wait for some time. So there is a word, there is a sentence or a question, it is mentioned wait for some time. After reading the data, we should wait for some time. Time is not mentioned here, so random time is selected. For x is equal to 0, x less than 40,000, x plus plus. That's why for variable 40,000, and because its integer variable is 16 byte, 68,000 times, we can make it actually, it's possible. Okay, whatever it may be. So what does this for loop is doing? It starts with the 0, every time increment the value x plus, and it will do nothing. Okay, is a symbol inverted or a semicolon represents, it's like NOP, a single NOP instruction in our. So it is doing nothing, just increasing the value every time, and then it checks whether it's less than 40,000 or not. Once it is less than 40,000, it will increment to next value, and then increment until it reach 40,000. Once x is incremented to 40,000, it is violated because 40,000 is not less than 40,000, then it will come out of the loop. That is what wait for some time. So microcontroller is forcefully setting into the idle condition for this duration by which x is incremented to 40,000 by the microcontroller. After then we have the statement P2 is equal to my byte. Whatever the data read from the port 1 will return into port 2 by the statement P2 is equal to my byte. Send it to port P2. So the simple program, scan port P1, wait for some time, send into. Again microcontroller scan the data, wait for some time, send into. So it will be a continuous loop. Every time it will read the status of the every bits of the port 1, wait for some time, and send it to port P2. Okay, so that is what meaning of programming of a port. Read from the port and also write to the port. So most of our microcontroller projects needs writing and reading from the ports, from and to the port. Okay, so many peripheral devices being interfaced to the microcontroller, so that communication is done by writing and reading data through and from to and from the port. Okay, so the understanding how to read from the port and how to write into the port is important in 8051 project design. Next. Second question, write an 8051C program to get a byte of data from P0. If it is less than 100, send it to P1, otherwise send it to P2. So here we need to same program, reading in some data from the port 0. We need to have a checking. If the read data is less than 100, we need to send the data to P1. Or if it is more than 100, we need to send into port P2. So this program is also very simple. Let us check how. Okay, so solution is #include reg51h. Okay, 8051 details are included, or header files are included here. Then in our main program, we have unsigned character byte and 8-bit data byte is, or a character byte is declared here. My byte is the data that is being copied from the port 1. And then again P0 is equal to, so here port data is being reading from the port 0, so P0 is equal to 0xxx 0xff. So we are writing logic 1 to every bit, so port 0 makes port 0 as input port. Then while true, while 1, meaning is this loop will be running forever, every infinite loop it is. Okay, always this is true, always while 1 means always it is true. Okay, it's like an infinite loop. Then my byte is equal to P0, whatever get data byte from the P0 and assign to my byte. Then we will compare my byte. If my byte is less than 1000, less than 100, that is what our question statement, less than 100. If this is true, my byte is less than 100, P1, that my byte will send it to P1, else P2 is equal to my byte. So if you want to implement this with the help of what you call assembly language program, it won't be as simple as like this simple statements. We cannot implement this with this simple statement. We need to bring them to the accumulator, then to the another register. We need to CP any compare and jump on not equal statement, then jump on carry, such instruction set we need to use to implement this program, and then there you may feel it is quite difficult. But here it is very simple. While true or while 1, we read data from port 0, then we will compare if my byte less than. If statement is very useful statement in C language. Hope you must be you might be knowing about these if else conditions in C plus or C languages. Okay, so very simple program. Next. Write an 8051C program to toggle only bit P2.4 continuously without disturbing the rest of the bits of port P2. Okay, so here so far we have modified all bits of the ports, or byte level programming we did. Here it is asked you to find to modify a single bit, port 2's 4th pin P2.4 only we need to toggle. So what do you mean by toggle? Toggle means keep it is high for some time, then low, high, then low, high, then low, like this. So we want to make P2.1, P2.4 as a logic high low, high low, high low condition continuously without disturbing the rest of the port P2. So port P2's remaining pins 2.3 to 2.0 and 2.5 to 2.7 we don't want to disturb. Only 2.4 will be affected with the help of with our program. That is what our program is saying. Let us check how it is. So program is quite simple, and program is hash include reg. Okay, I don't want to explain to you again. And the statement S bit, hope you might be knowing the data types, characters, data types in the 8051C programming. S bit means single bit. S bit means single bit. So we are defining here a single bit. My bit is equal to P2.4. So the bit data type and S bit data type you might be knowing. S bit is using for assigning a particular pin of the special function register, and the bit is for assigning bits from what you call the bit addressable memory. Okay, so S bit and bit. So here P2.4 is from special function register. That's why we used here S bit. If you use bit, it will make an error while you compile your programs. Okay, so S bit, my bit is declared here as port 2's 4th pin. Okay, so P2.4, actually it is 5th pin, P2.4. Then main program while true. Okay, forever it will check. Then first we'll assign my bit is equal to 1. So P2.4 will keep logic 1. Then after one system clock cycle or one machine cycle, we discussed about this machine cycle yesterday's class. So after this 12 clock cycle, one machine cycle or 12 clock cycle, or around 1 microsecond, or after 1 microsecond, what will happen? My bit become 0. So that bit goes low after 1 microsecond. Then again it will continue with my byte is equal to my bit is equal to 1. So it will go high, then low, then high, then low. So at pin 2.4 of our 8051 microcontroller, we will be getting a 2 microsecond square pulse, square wave. Okay, so this is a method of generating a square wave in any of our port. Okay, they may ask you to generate a particular frequency square wave at a particular pin of your microcontroller. So the technique is declare a single bit, which pin is mentioned in your question. Then with after my bit equal to 1, you need to provide a proper delay according to what frequency it is asked you to. Okay, frequency, how can you find frequency? From frequency question it will be mentioned. From that time period is given by 1 by f. Then 1 by f you need to split into 2, 1 here, 1 here. So here introduce a delay for half of this time period, and here another delay, another half of this time period. So here by default our microcontroller, if f is of 12 megahertz, if f is of 12 megahertz, this is of 2 microsecond. Then with the same 2 megahertz or 12 megahertz, we can go for a high time period signal, or still what you call low frequency square wave at any of our ports. So this is the maximum frequency that we can get from our that we can design for with our any of the port pins of our microcontroller. The system clock frequency only we will get. We cannot prepare a wave with more than that frequency. Okay, that's because of the frequency limitation or machine cycle duration problem. Okay, next. Write an 8051C program to monitor bit P1.5. If it is high, send 55 to P0. Otherwise, send AA to P2. Okay, so question is very clear. We need to write the program. We need to monitor P1.5. So port 1's fifth line, P1.5, we need to check. Okay, then if it is high, if it is with the 5 voltage, we need to send 55. So what is actually 55? 0 1 0 1 0 1 0 1. Okay, so 0 1 0 1 5 5. Okay, if the bit P1.5 is high, we need to send this to port 0. Otherwise, send AA. So AA means 1 0 1 0 1 0 1 0. Okay, 0 become 1, 1 becomes 0. So this is 8 plus 2 10. 10 is A actually. So 55 AA. So this we need to send it to port 0. This we need to send to port 2 according to P1.5 status. If high, send P0 to 55. Otherwise, send it to P2 with the data AA. Okay, so let's check how we can. Then statement is rejects reg 51 actually. Then set bit my bit is equal to P1 raised to 5. Okay, it's like 1.5 in assembly level programming. The void main is my bit is equal to 1. Okay, make my bit as input port. So because why this statement, we need to configure port 1.5 as only 1.5. We don't want to configure other bits of the port 1. So my bit is equal to 1 first. Okay, now while true for infinite loop. If my bit is equal to 1, okay, after this is not from the same what we wrote here. This the system will be writing to the port latch. While we discussed about the structure of the port, writing to the port affects the port latch, and my bit is equal to 1 will read from the port pin. So both are different actually. This is no this same what we wrote here is that is wrong. This is for configuring the port as input port. This is the status of the port pin. If we applied external 5 volt to port 1.5. Okay, so my bit is equal to 1 will write 1 to port latch. Okay, writing port 1 to latch, make port as input. Okay, then 1.5 we can apply some switch. By switching on, some 1.5 voltage will come here. Sorry, some 5 voltage will come here. Then microcontroller will read the data. So while reading, microcontroller will be reading from the port pin. While writing, microcontroller will be writing to the port latch. The both are different in the port structure. So if my bit is equal to 1, our case is P0. Port 0 is equal to 0x55. That is what it is mentioned in port in our question. Port 0 is will be written with 55, and else if my bit is not equal to 1 means what? If it is ground, if it is at the ground level or a 0 logic 0, port 2 will be written with AA. Okay, so that is what our simple program. Same, if you want to implement the same program with assembly language, it won't be that easy as it is here. Okay, it will be difficult. So that is the advantages of using C-level programming for 8051 microcontroller. Okay. Next, a practical problem. A dose sensor is connected to port 1.1 pin and a buzzer is connected to port 1.7. Okay, then write an 8051C program to monitor the dose sensor, and when it opens, sound the buzzer. You can sound the buzzer by sending a square wave of few hundred hertz. Okay, while reading the problem, you may feel that it is so difficult, but it is not actually. It's not that difficult. This, with the help of C language, it is very simple. So what the question is saying, we have our microcontroller P1.1. So P1.1, we have to monitor this pin. Okay, a buzzer is connected to P1.7. So P1.7 is having a buzzer. So buzzer, how we can indicate a buzzer? A buzzer is a device which makes a sound when some voltage or current flows through. Okay, so this is the buzzer connection. Okay, it produces sound. It produces sound when a 5 voltage will come to. Okay, so tick 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 sound we can make when 5 voltage. When we write logic high, it make a tick, then off. Okay, so buzzer will make tick 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 with the help of the. Whenever we write logic 1, it make tick. When we make it slow, it will not make. So tick. then tick, then tick. That is what a buzzer is. Okay, or continuously if you write to 1, we'll get a tick instead of tick tick tick, you will get a tick or a continuous sound. Okay, I cannot make that sound here, so some long making sound or the disturbing sound it will be producing. Okay, so that is what a buzzer means. You can sound the buzzer. So in the Hindi is given here by sending a square wave of few hundred hertz. Okay, so question is very clear here how we can implement this. So we have a door here. So on your door part, okay, on your moving arm, you can implement a door sensor. Okay, on other side you have another metallic part. This metallic part you can connect it to ground, and to this metallic part, so this part, these two metallic parts we need to fit into the this to the what you call the door fixed side, and this is the moving side. Okay, then this part is we have a simple circuit and a 5 voltage here, and this is a 1 kilo ohm resistor. So okay, so when door close, this will come in contact, two metallic parts will come in contact, and this ground will come here, so that 5 volt circuit will complete, and you need to connect this to port 1.1. Okay, so what is actually happening here, when you open the circuit, this ground will be disconnected from the circuit. So which voltage will be available to your port? It will be 5 voltage. When you close the circuit, these two metals will come in contact, so here this ground will come, so which voltage is available to P1.1? Which will be 0. So when you open the door, immediately our microcontroller will monitor that somebody opened the door. Okay, so as long as while P1.1 is true, that might be your program, while P1.1 is equal to true, what we need to do, P1.7 we will write with the logic high, then we'll wait for some time. Okay, then we will write P1.7 with the logic 0, we'll wait for some time, and so this we need to make it to an infinite loop. Okay, so when this P1.1 is true, that time only, when somebody close this condition, this while loop will violate. So what will happen? It will so better we will not keep this in while loop, instead in if else loop. Okay, or some other loops we can use. Let us check how we can implement this program. Okay, so this is the technique, this is the hardware part that we need to implement with the this simple project. Okay, let us check how we can implement this. Okay, so program is very simple. We have the delay. Yesterday's class we discussed about the millisecond delay unsigned integer. So this number indicates, if you write here while calling this subroutine, if you write here 250, pass the argument as 250, it will wait for 250 microseconds. Okay, so day sensor is P1.1, sensor is connected to P1.1. For that, our metallic part that we explained before is connected to what you call the P1.1. Okay, so that is P1.1, and the buzzer is connected to P1.7. so here is our buzzer. Okay, buzzer make 5 measuring, no need to explain again. Okay, P1.7 is defined as or declared here as single bit with the buzzer. Okay, so when you use the buzzer, it is nothing but P1.7. then main program, D sensor is equal to 1. I don't want to explain to you why this statement, it is compulsory. Okay, to keep P1.1 as an input. Then while 1, fine for an infinite loop. While then inside the while loop, while D sensor is equal to 1, or while somebody opens the door, what will happen? Ground will be disconnected, so it become 1. So while it opens, so while D sensor is equal to 1 means when microcontroller read a logic 1, as long as it is logic 1, that is what this while sensor. So while D sensor is equal to 1 means as long as this P1.1 is logic 5, that means as long as the door is open. So buzzer first we will write 0, then wait 200 milliseconds, then D sensor is equal to, buzzer is equal to 1, then wait for another. So again it will check D sensor is still high, again it will produce. So first it will produce logic low, then logic high. This is 200 millisecond, again logic high, logic low. Okay, so 400 milliseconds duration. So time is 400 millisecond here for our clock signal, for our square signals. Time is equal to, time period is equal to 400 millisecond, is equal to 400 into 10 power minus 3, and the frequency is equal to 1 by t, which is equal to 10 power 3 divided by 400, which is equal to 1000 divided by 400, then 10 by 4. Okay, 10 by 4 hertz, only very low frequency actually, but the question is mentioned, it's a few hundred hertz is mentioned here. We don't want to go for, so just to decrease the time period to 100, so frequency will increase. Okay, whatever be the frequency, we will get that sound from our buzzer. Okay, so that is what our simple program. Another practical application to port programming will, the data pins of an LCD are connected to port 1. So LCD, actually we are going to learn about this LCD interfacing in next class or in the coming class. Information is latched into the LCD whenever its enabled pin. Enabled pin goes from high to low. Write an 8051C program to send the earth is but one country to this LCD. Okay, so LCD's liquid crystal display might be experience the use of this LCD in many projects on a printer or some electronic items. You might be seeing this LCD. Okay, LCD is a display device actually. So it's also having 8 data pins. So in our LCD there will be 8 data pins. We will mark it as D0 to D7. So in our microcontroller also, what it should be connected to P1. So P1.0 we need to connect to D0, then etc. P1.7 we need to hardware connection to D7 of our LCD. So this is our LCD, this is our microcontroller. Then there will be one more pin, not only one more, there are a few more pins. We will study in detail what are the other pins, and this one pin is not enough to control the LCD actually. So there is a latch inside. Whatever the data available from our microcontroller, that will be latched or temporarily stored in the register inside our liquid crystal display. For that there will be an enable pin. That enable pins must be sent high low. Okay, goes from high to low. We need to make a pulse like this. Okay, so this data will go inside our microcontroller. Then we need to write pulse that we not mentioned in this question while discussing or while we are studying about this interfacing of LCD. That time we will discuss how we can read or write the data. So after this latch pulse, we need to give a write pulse. Okay, write pulse to our LCD, then only the display will get modified. Okay, so what it is saying, whatever the data coming from the port 1 will be latched into our microcontroller. The data is mentioned here. The earth is but one country. Earth is but one country. So this is a string statement. This string entire characters have to be sent to our LCD, while then we need to make the enable pin a high low. So whatever be the data will latch into our LCD one by one. So let's check how we can implement this simple project. Okay, so the program is, as usual, we have the Reg 51, then LCD data is defined where we connected our LCD, it is to port 1, then enable pin is connected to, pin is not mentioned here, so we have selected port 2 0th pin, P2.0 as our enable pin of. So from our microcontroller port 1 we need to connect to LCD, then LCD data pin, then enable pin we should connect to P2.0 as per our program. Then main program, then there is a character message with the declared as array. So the earth is but one country. So you might be knowing what is the importance of keeping all entire things in the inverted comma, double inverted quotes. These characters will be stored as its ASCII characters. So inside our microcontroller, every or continuous memory locations will be loaded with the ASCII character. For example, from 30 onwards, 30 will be having the what you call the ASCII character of T, then 31 will be having the ASCII character of H, then 32 will be having the ASCII character of E, 33 will be having the ASCII character of space, then etc etc etc. Continuous memory locations will be loaded with the corresponding ASCII characters of each of these letters in order. Okay, so who will decide? Assembler will or compiler will decide where to send this character string. Okay, then unsigned character Z. So we cannot send the whole bits, whole characters at one time. Instead, we will be sending what you call the character by character. For that, we need to know how many characters are there in our message. So message is having 3 plus 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. There are 28 characters in our in our message. That's why Z is equal to 0 to 28. Then LC data is equal to message of Z. First message of 0, T will be sent. Then we will make enable pin high to low. So this is very important. So at the time of discussing about interfacing of LCD, it will be very easy for you to understand. First we will send the ASCII value of T. First we will send the ASCII value of T to port 1. Then we will make 2.0 as high low. Okay, then we will send ASCII value of H, then ASCII value of H or small letter H. Then we will write high low. Okay, so again next we will send the ASCII value of Z will be 2. Then Z message of 2 will be E. Then we will write high low. Okay, every time each character is being sent to port 0, port 1, port 2.0 will make a high low. That high low is actually take the data from our port to the sum of the register inside our LCD. Okay, so not only to that their data character is being displayed to our LCD, we need to write few more characters, few more pulses here. That is not actually needed here. That is not mentioned in your question. Only program is saying to latch the data. While we discuss about the interfacing of LCD, we will study in detail. Okay. So that is what this program. Next simple program, that will be my last program anyway. Write an 8051C program to toggle all the bits of P0, P1, P2 continuously with 250 millisecond delay. Use SFR keyword to declare the port address. Okay, purposefully this program I have included to used. You should know how to use SFR keyword. So program is very clear. We need to toggle all the bits. What do you mean by toggle? We discussed this. We used this word toggle before. Toggle means first high then low, high then low. So high means 1 0 1 0. Okay, so first we need to write with the data 1 0 1 0. What is this data? AA. After then we write V0 1 0 1 0 1 0 1. Okay, so this is to port 0. Similarly, you should write the same data to port 1 and port 2. So first write with the AA, second write with the FF, sorry, 55. AA makes 1 0. First time, so for example, this is for P1.7, P0.7, then again this is P0.7. So for some duration, about 250 millisecond, P0.7 is logic high. After that, for another 250 millisecond duration, P0.7 will be low. Same time, P0.6 will be at the first, it will be logic low. Then while this will go to logic 0, this will go logic high. So alternately, it will make a 1010 pattern on your every ports of your microcontroller. If you connect an LED to the ports, you can experience the LEDs. So LEDs, many LEDs are connected here. Off, on, off, on. Same time here, on, off, on, off. So off, on, off. So here also on, off, here also on, off. Such a pattern you can experience with the help of this simple project. Okay, so we need special cases. We need to use the SFR instead of P0, P1. We should have to use SFR keywords. That's also SFR, special function register keyword, in our microcontroller. So program, it's important. Every program, while we discussed with the port programming or delay programming, while the program is of what you call the embedded C, we used to use hash include statement. That is not included here. We don't want to use that statement because P0 is declared here with the SFR. Okay, actually, a microcontroller to be known by as P0, we should include reg 51.h. Then only microcontroller will understand what is the meaning of P0. If you are not declaring or not introducing this header file, we need to declare that variable as a SFR variable. SFR P0 is equal to 0x80. You must know the address of what you call port 0 if you are not using the reg 51. Okay, if you are using Reg 51, we don't want to know about the address of what you call the each ports. Okay, you can use directly P0 in your program, P1 in your program, P2 in your program. But as a to experience the use of this SFR, that's what the question is saying. I have purposefully avoided that use of the Reg 51, and we declared at the beginning what you mean by P0. P0 is 0x. So whenever you use P0, the address 80 will be affected. 80 is known by the microcontroller where it is. It is the port P0 of the microcontroller. So for port 90, it is P1. Address 90 is of address of P1, and address 80 is of port P2. Then MS delay and signed integer. We declared a function here. Okay, that function, no need to explain to you again. MS delay function will be having is that the variable listening to 1257, 1275 some variable. Then that we already discussed MS delay, how to make a 1 millisecond delay. We can pass the argument if you want 250, send call the function with the 250 here. Okay, while true means for infinite loop. First we will write F55 to port 0, 55 to port 1, 55 to port 2, then we'll call the delay. Okay, so we will write 101010, 101010 to every bits of your ports 0, 1, 2. Then we'll wait for some time, 250 microsecond, or sorry, 250 millisecond, or 500 millisecond, or 1000 millisecond, whatever it may be. Then again we will wait for, we will write P0 with the AA. So first it 0101, same time after 250 milliseconds it will make 1010. So A, this is 5, this is A. Again another 0101, here another 1010. So that's what it will toggle every bits of your microcontroller ports P0 to P1 and P2. After then again wait for 250 milliseconds, then this repeat. Okay, so program is very simple. What advantage or a special case here is, if you are using SFR, we don't want to include these Reg 51 header files. So the port we should declare at the beginning with the use of what's called SFR data variable. Okay. Then one more program is there. I would like to give this as an assignment to you. If you are interested, you can try yourself. Write an 8051C program to get the status of bit P1.7. So get status of bit P1.0 means you should configure P1.0 as input port. Then okay, save it and send into port 2.7 continuously. Save it means you can save it means you can write that status of P1.7 1.0 to any of our internal bit addressable location and send into P2.7 continuously. I will be just showing the, I am not going to explain to you how it is. I will be just showing the program. This is the program. Okay, set bit, single bits are declared here, single bit. Okay, P1.0 and 1/2.7 are single bit. See here the difference, bit. Bit is used here. Bit will be from our internal memory. Why this here S bit, say single bit? It's because of port. Okay, this is from internal memory. Then main program is very simple, even though if you look the statement, you feel that it is very difficult, but the program is very simple. Okay, so that is what our program, and this is with the end of the programming of ports.